What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into Amazon Web Services Lake Formation, data lake governance, and fine-grained access. Let's get into it. By the end of this video, you'll know exactly when to reach for lake formation. And that decision shows up on 6 to 10 questions on the Amazon Web Services Certified Data Engineer Associate exam. Most of those questions are designed to bait you toward the wrong answer. Today we fix that for good. Here's a scenario you will see on exam day in some form, almost guaranteed. Nexer Retail has analysts in 12 countries. Each analyst should only see sales data for their own country. The data engineer needs to build this. What's the answer? Take a second. The trap is that 3 of the 4 options will sound completely reasonable. It's not Redshift views. It's not 12 separate tables. It's not clever IAM policies. The answer is lake formation row-level security, and it's the right answer for somewhere between 6 and 10 questions on your exam. This is one of the highest yield topics in the entire certification, and the gotcha potential is enormous. So what is lake formation actually doing? It's a centralized governance service for data lakes sitting in S3. The critical thing to understand is that it's built on top of the Glue data catalog. It does not replace the catalog, it adds a governance layer above it. The permissions model is exactly like a relational database. You write grant and revoke statements against catalog resources, which makes it feel familiar to anyone with a SQL background. And lake formation enforces fine-grained access all the way down to the database, the table, individual columns, individual rows, and even individual cells. There are 3 layers in the Amazon Web Services data lake governance stack, and the exam expects you to understand how they cooperate. At the top, IAM decides which Amazon Web Services AP is you're even allowed to call. In the middle, the Glue data catalog holds the inventory, every table, every schema, every S3 location. And at the bottom, lake formation governs which actual rows and columns you can see inside those tables. 3 layers, 3 jobs, they are not alternatives to each other. Picture a museum. All 3 of these services are doing different jobs in the same museum. They cooperate, they don't replace each other. IAM is the security guard at the front door, checking whether you're allowed in the building at all. The Glue data catalog is the index card system behind the scenes, tracking every artifact and which room it lives in. And lake formation is the docent standing at each exhibit, deciding which paintings you're allowed to view, and even which details of each painting you can examine up close. All 3 have to say yes before you see anything. Here's how Amazon Web Services describes it in the official Lake Formation Developer Guide. Lake Formation provides its own permissions model that augments the IAM permissions model, enabling fine-grained access to data through a simple grant or revoke mechanism, much like a relational database. Notice that word augments. It doesn't replace IAM, it adds a second layer on top. Let's lock this distinction in because the exam loves to contrast these 2 side by side. On the left, IAM controls service level access. It decides whether you can call Glue get table or S3 get object. Its course, entire buckets, entire prefixes, entire AP is. It cannot filter by row or by column. On the right, lake formation controls data level access inside tables. Its grants look like select on a specific column with a where clause filtering rows. And the crucial rule, both IAM and lake formation must approve the request or it fails. If you remember nothing else from the IAM comparison, remember this exact sentence from the docs. When a principal makes a request, for the request to succeed, it must pass permission checks by both IAM and lake formation. Both. Not either. That's the test answer when a question asks how the 2 services interact. Here are the 3 levels of fine-grained access, and you need to know all 3 by name. Row-level security filters which rows the user can see, for example, only rows where country equals US. The filter expression uses partiQL where clause syntax. Column-level security filters which columns are visible, show name and email, but hide social security number. And cell-level security is row and column filtering combined into a single rule. Hide the SSN column and also hide every non-US row. That's cell level. It's the most powerful form of fine-grained access in the entire Amazon Web Services analytics stack. And here's the official line from the docs that defines the distinction precisely. All columns plus a row filter, that's row-level security. Specific columns plus a row filter, that's cell level. Memorize that pattern. The exam will phrase the scenario, and you need to map it back to the right name. Here's the mental model that makes this click. Imagine Nexer Retail has one global sales table with rows for every country. Instead of making 12 copies of that table, Lake Formation puts a different pair of glasses on each analyst. The French analyst's glasses automatically hide every row that isn't France. The US analyst's glasses hide every non-US row. Same table, same query, completely different results per person. One source of truth. That is why the exam answer is never separate tables or Redshift views. So how do you actually express those rules? You create a data filter. A data filter is a named Lake Formation object that bundles 2 things together, a column specification and a row filter expression. The row filter is partiQL where clause syntax, like country equals US. The big win is reusability. You write the rule once, then attach it to grants for many different principles. One limit to keep in mind: 100 data filters per principal per table. For governance at scale across many catalog objects, LF tags are the recommended approach, and we'll cover those next. LF tags, also called tag-based access control, are the scaling solution for governance. You attach key value labels to databases, tables, and columns. Then you write grants against tag expressions rather than named resources. For instance, classification equals PII and department equals finance. The killer feature: new tables with matching tags inherit permissions automatically, no new grants needed. When somebody creates a new table next month and tags it the right way, all existing grants apply to it instantly. This is why Amazon Web Services officially recommends LF tags as the default approach when you have lots of catalog objects. Think of it this way: per table grants are like writing a separate guest list for every single party in a building. 50 parties, 50 lists, and you have to update all of them every time a guest joins. LF tags are colored wristbands at the door. Green wristband gets you into every green tagged room. Add a new green room next week. The wristbands already work. That's the operational shift. Here's the math behind why LF tags scale and named resource grants don't. With named resources, the number of grants you need is principals times resources, that's multiplication. With LF tags, the number is principals plus resources, that's addition. Multiplication versus addition is the whole story. Linear growth instead of explosive growth. That single shift is what turns an unmanageable governance mess into something a small team can actually run. Take 100 principals and 100 tables. Named resource grants, that's 100 times 100, 10,000 individual grants to write and maintain. Every principal needs an explicit grant on every table, and the cost compounds with every new hire and every new dataset. Now flip the model to tag-based access control. LF tag grants, 100 plus 100, just 200 grants total. Same coverage, 2 orders of magnitude less work. This is why the exam answer for managing permissions across thousands of tables is always LF tags, never per table grants. Now let's talk about the single most important setup step. Registering an S3 location means telling Lake Formation this S3 path is yours to manage. You hand it an IAM role, and Lake Formation uses that role to vend short-lived temporary credentials whenever someone queries the data. This is the single biggest setup gotcha on the exam. If you don't register the location, Lake Formation permissions are not enforced at all. Queries fall back to raw IAM and S3 bucket policies, which means your beautiful row-level security does absolutely nothing. Registration is the linchpin. And there's a second setup gotcha that's even sneakier. By default, Lake Formation includes a backward compatibility group called IAM Allowed Principals, which grants super permission on every catalog resource. That's their pre-Lake Formation glue setups don't break the moment you enable the service. But until you revoke it, every Lake Formation grant you write is silently doing nothing. The exam loves this scenario. The setup looks correct, the grants look right, but users still see everything. The answer is always revoke IAM Allowed Principals. Once you've registered the location and revoked the backward compat group, the magic starts. Every major analytics engine automatically respects Lake Formation permissions. Athena enforces cell-level security in Engine version 3 in all regions. Redshift Spectrum applies the row and column filters at query time. EMR, including EMR on EKS, supports fine-grained access control. And Glue ETL honors permissions when reading registered locations. One governance layer, every engine. Cross-account sharing is the other big Lake Formation answer pattern. Picture a data mesh setup. The producer account on the left owns the S3 data lake and runs Lake Formation. They write a single grant using LF tag-based access control, and that grant can target a specific consumer account, an entire Amazon Web Services organization or OU, or a list of named accounts. The consumers then query through Athena, Redshift Spectrum, or EMR as if the tables were local. And the critical detail 0 S3 data is copied. The shares are references only. And now, the number one trap on this entire topic. Lake Formation versus Glue DataBrew. DataBrew is a visual data preparation service in the Glue ecosystem, and the exam writers know it's an easy distractor to drop into governance questions. Lake Formation is governance. Who can read which rows and columns, permissions, grants, audit, cross-account sharing? DataBrew is data preparation, visual, no-code cleaning, transforming, normalizing, deduplicating. DataBrew has no permissions model at all. So whenever a governance question lists DataBrew as an option, cross it off immediately. It is always the wrong answer. Here's the analogy that keeps these two straight. DataBrew is the prep cook in the kitchen, washing the vegetables and chopping the onions. Lake Formation is the maitre d' at the front, deciding which guests can order which dishes off the menu. Both work in the same restaurant. They have completely different jobs. If the exam asks about who gets to see what, you want the maitre d' every time. Before we wrap, here are the gotchas the exam loves. First, forgetting to revoke IAM allowed principles, your grants silently do nothing. Second, not registering the S3 location, which means Lake Formation is not enforced at all. Third, confusing IAM tags with LF tags, they are not interchangeable. IAM tags drive IAM policy conditions, LF tags drive Lake Formation grants. Fourth, watch out for column-restricted grants on older Glue ETL versions, where jobs will fail outright unless you check version compatibility. And fifth, trying to column filter a partition key is simply not allowed by the service. Remember those 5 traps, and you'll dodge the questions the exam writers love to set. Here's your exam decoder, the keyword to answer mapping. Row, column, or cell-level security points to Lake Formation fine-grained access. Analysts only see their country or region points to a lake formation row-level data filter. Manage permissions across thousands of tables points to LF tags. Share data lake tables across accounts points to lake formation cross-account sharing. And the broadest one, data lake governance, always points to lake formation. So here are the 7 things to remember. Lake formation sits on top of the Glue data catalog. They cooperate, they don't compete. IAM handles service-level access, lake formation handles data-level access, and both must pass. Row, column, and cell-level security is the answer when IAM alone cannot do the job. Data filters are your named, reusable rules. LF tags scale grants from n times n down to n plus n. Register the S3 location and revoke IAM allowed principals. Those are non-negotiable setup steps. And remember, DataBrew is data preparation, never governance. It is always the wrong answer here. Now let's see how well you absorbed all of this with a quick 5-question quiz. Question 1. A retailer's data analysts in France should only see sales rows where country equals FR, and analysts in Japan should only see country equals JP. The data is stored in a single S3 table queried via Athena. What is the recommended solution? Is it A, create separate S3 tables per country and use IAM policies? B, use lake formation row-level security via data filters on the single table? C, create Redshift views with where clauses per region? Or D, use Glue DataBrew to split the table into per country outputs? Take a moment to think about it. The answer is B. This is the textbook lake formation row-level security scenario. One data filter per principal, one source of truth, and it works automatically with Athena. Separate tables and Redshift views are exactly the wrong answer. Traps the exam plans here. Question 2. A data engineer has configured lake formation grants for a sensitive table, but users still see all data. The S3 location is registered. What is the most likely cause? Is it A, the IAM allowed principals default group still grants super permission on the table? B, the Glue data catalog needs to be re-indexed? C, the table storage class must be changed to intelligent tiering? Or D, Athena requires a VPC endpoint to enforce lake formation permissions? Take a moment to think about it. The answer is A. IAM allowed principals is the backward compatibility default that grants super on every catalog resource. Until you revoke it, every lake formation grant you write is silently ignored. This is the classic invisible bypass gotcha. Question 3. A governance team needs to manage permissions across roughly 3,000 tables for 200 principals, with new tables added weekly. They want minimal grant maintenance. Which approach should they use? Is it A, write named resource grants for each principal table combination? B, use Glue DataBrew recipes to enforce access rules? C, use LF tags, also known as lake formation tag-based access control? Or D, write IAM policies with resource-level ARNS for each table? Take a moment to think about it. The answer is C. LF tags shrink the grant count from n times n down to n plus n, and new tables with matching tags inherit permissions automatically. Option A would require 600,000 grants, completely unmanageable. And DataBrew is a preparation tool with no permissions model at all. Question 4. A central account needs to share specific data lake tables with multiple consumer accounts in an AWS organization without copying the underlying S3 data. Which AWS feature enables this? Is it A, S3 cross-region replication to each consumer bucket? B, Redshift data sharing with consumer clusters? C, lake formation cross-account sharing with LF tags using cross-account version 3? Or D, Glue ETL jobs that copy filtered subsets to each account? Take a moment to think about it. The answer is C, lake formation cross-account sharing with LF tags, And cross-account version 3 lets you target individual accounts, AWS organizations, or entire OS. The consumers query through Athena or Redshift Spectrum as if the tables were local, and zero S3 data is copied. Redshift data sharing is the wrong scope. That's for Redshift clusters, not data lake tables. Question 5. An analyst is granted a lake formation column-level filter that excludes the region column from a sales table. The table is partitioned by region. What happens when the analyst queries the table? Is it A, the query succeeds and the region column is returned as null? B, the grant fails or the query is denied? You cannot exclude a partition key with a column filter. C, the query succeeds and Lake Formation silently rewrites the partition layout. Or D, the analyst sees the region column but only for rows matching their IAM tags. Take a moment to think about it. The answer is B. Lake Formation does not let you hide a partition key with a column-level exclusion, because the partition key is required to physically locate the data in S3. If you need to restrict access by partition value, you use a row-level filter expression instead, something like region equals US. And that's a wrap on Amazon Web Services Lake Formation, data lake governance, and fine-grained access. If this helped you out, smash that like button and subscribe for more. See you in the next one.